Welcome back to a new episode of One Wingspan Above, where we discuss anything to do with ground effect. My name is Paul Dutch. In this episode, we're diving into something truly special, rare footage from Eages 2001, the International Ground Effect Symposium from many years ago that brought together some of the most brilliant minds in wing and ground effect technology and uploaded to the YouTube channel of SSG Aero. Eages stood for EuroAvia Ground Effect Symposium, held in Toulouse, France, from June 12 to 15, 2001. This wasn't just another academic conference, it was a historic convergence of pioneers who had been working often in isolation on one of the aviation's most fascinating frontiers. The symposium was organized by EuroAvia Toulouse, a student aviation association in partnership with SSG Aero. Their goal was ambitious: gather the world's leading experts on ground effect craft and make this cutting-edge knowledge accessible to students and future engineers. What made Eages 2001 so special was the caliber of attendees. This symposium brought together pioneers from both sides of the Iron Curtain. From Russia, Sinitsyn and Alexander Maskalik, direct followers of Alexeyev, the Soviet engineer who created the famous Ekranoplan program, including the massive Caspian Sea monster. Professor Rozhdestvensky, a leading theoretical scientist in extreme ground effect aerodynamics. From Germany, Hanno Fischer, who worked directly with Alexander Lippisch in the 1970s on the revolutionary X113 and X114 craft. Gunther Jörg, inventor of the Tandem wing configuration for ground effect craft. From the Netherlands, Edwin van Opstal, a leading expert in wing hydrodynamics and design. From the UK, Graham Taylor, a practical model builder demonstrating hands-on approaches to wing development. And many others. Let's do a quick summary of what is discussed in each of these videos so you can go and watch them online. Edwin van Opstal opens the symposium with a comprehensive overview of wingcraft technology. He explains how these vehicles operate between traditional aircraft and boats, utilizing ground effects to achieve remarkable efficiency gains. Van Opstal breaks down the aerodynamics of span-dominated ground effect, showing how proximity to the ground reduces tip vortices and induced drag, allowing wingcraft to create more lift with less power than conventional aircraft. He compares the power requirements of wingcraft to both high-speed boats and hovercraft, demonstrating their superior efficiency. The presentation also covers the regulation landscape, discussing the proposed Type A, B and C classifications for wingcraft based on their ability to operate in and out of ground effect. Van Opstal emphasizes that while aerodynamic and hydrodynamic challenges have largely been solved, the path to commercialization depends on overcoming operational cost barriers and regulation hurdles. He identifies promising markets in regions with favorable wave conditions, like the Caribbean and Mediterranean, where wingcraft could revolutionize coastal and inter-island transportation. Hanno Fischer presents his innovative Hoverwing concept, which bridges the gap between air-cushioned vehicles and wing and ground craft. Fischer traces the evolution from his work with Alexander Lippisch on the X113 single-seater military craft through to the development of the Airfish series. He explains how power augmentation systems, successfully employed in Russian designs, were incorporated into his approach to solve the critical takeoff problem that plagued many ground effect vehicles. The highlight is the Airfish 8, designed to meet specific investor specifications and successfully tested in Australia. Fischer demonstrates that his craft achieves automatic stability, allowing hands-free operation without requiring a pilot's license. the design philosophy focuses on achieving optimal lift-to-drag ratios while maintaining stability during takeoff and landing. Fischer addresses the economic viability of ground effect craft, emphasizing their low production cost compared to traditional aircraft and discussing market potential in regions like Baltic Sea. Dmitry Sinitsyn presents a Russian perspective on Ekranoplan development, showcasing the evolution of these massive craft from Alexiev's pioneering work. The presentation includes rare footage of the enormous Ekranoplans in operation, including craft weighing 140 tons, demonstrating remarkable performance in various weather conditions. Sinitsyn emphasizes the critical importance of stability design requirements that fundamentally shaped Russian Ekranoplan configurations, particularly the relationship between the tail unit size and longitudinal stability during cruising flight. The presentation transitions to the commercial Aquaglide technology, which successfully integrated features of boats, helicopters and hovercraft into a practical craft capable of operating on water, land, snow and ice. Sinitsyn discusses the successful trial operations in locations including Norfolk, Virginia, Freeport, Bahamas, highlighting the craft's amphibious capabilities and unique passenger experience. He presents mathematical models, illustrating the complex relationship between height, speed and stability, emphasizing the importance of automatic control systems for managing the dynamic behavior of these vehicles. Professor Rozhdestvensky delivers a masterclass in theoretical foundations of extreme ground effect. He explains how the complexity of three-dimensional flow problems can be simplified through asymptotic analysis, making extreme ground effect more mathematically tractable than conventional flight regimes. Rozhdestvensky introduces sophisticated mathematical modeling techniques, including the application of boundary conditions and the Kota-Joukowski condition to understand lift generation when ground clearance approaches zero. The presentation emphasizes the fundamental differences between ground effect vehicles and conventional aircraft, particularly regarding stability. While aircraft can adjust their center of gravity to improve stability margins, ground effect vehicles must be designed correctly from the outset, as their stability characteristics differ fundamentally from free-flight aircraft. Rozhdestvensky cautions against applying standard aviation principles like superposition of effects to extreme ground effect scenarios, as the highly nonlinear nature of the flow requires entirely different analytical approaches. His work provides the theoretical foundation that supports practical design decisions. Alexander Maskalik provides insider perspective on the main research problems encountered during Russian Ekranoplan development. He explains that these craft were developed by shipbuilders rather than aviation specialists, which profoundly influenced their design philosophy. Maskalik traces the lineage from Alexiev's hydrofoil work, explaining how the wings of an Ekranoplan can be seen to be related to the underwater hydrofoil wings, a crucial insight that guided early design decisions. The first prototype, launched in 1960, featured a tandem wing configuration exploiting ground effect for stability. The presentation chronicles the development of the legendary KM Caspian Sea Monster in 1964, weighing over 500 tons and achieving speeds exceeding 500 km an hour while operating in rough seas. Maskalik discusses the transition to second-generation commercial designs in the 1970s, including modern developments like the certified Aquaglide. He candidly addresses ongoing challenges, including automatic stabilization systems, engine performance near water surface, reducing takeoff and landing speeds, and developing engines optimized for marine environments. These technical hurdles remain critical for expanding commercial viability and achieving international certification. Gunther Jörg presents his innovative Flareboat design, which takes off at approximately 50 km an hour and flies 40 cm above the water, achieving remarkable fuel savings of up to 85% compared to conventional boats. Available in 2, 4 and 9-seater versions, these crafts cruise at 130 to 140 km an hour with remarkable efficiency. Jörg, a former pilot and aeronautical engineer who invested $2 million into the project, explains a tri-hull design where the center hull carries passengers, while outer hulls provide stability supported by aluminium wings that prevent flipping during flight. The presentation details the craft's 3 operational modes: floating, gliding and flaring, each with different fuel consumption characteristics. Jörg demonstrates that fuel consumption is highest during hydrostatic lifting at low speeds, but decreases dramatically as the craft transitions to aerodynamic lifting, potentially achieving 50% of speed using only 30% of fuel. Safety during turning maneuvers close to the water surface is carefully addressed, with design features that maintain stability even when one wing moves towards the surface. Jörg envisions larger 400-seat models for rougher sea conditions, positioning the Flareboat to bridge the gap between traditional ships and aircraft in the extensive water transport market. Graham Taylor provides an accessible, practical guide to building working wing models, demonstrating that ground effect concepts can be explored with minimal facilities and lower cost. Over 20 years of experimentation, Taylor developed a series of models from Mark 1 through Mark 6, each iteration revealing important insights about ground effect behavior. He explains the fundamental challenge: while wingcraft can fly efficiently, the real problem is generating enough power for takeoff, leading him to experiment with air cushion systems as liftoff aids. Taylor emphasizes simplification as the core design principle, describing how his Mark V model successfully achieved true ground effect flight over both grass and water. He contrasts flying with an air cushion versus true ground effect, showing photographs that clearly demonstrate the lack of water disturbance when operating correctly. His presentation covers material selection, balsa wood, plywood and foam, the advantage of electric motors for experimentation, and critical considerations like center of gravity placement and wing design. Taylor argues that practical experimentation with models can provide more insights than extensive theoretical discussions, demonstrating that one successful model flying in ground effect teaches more about the phenomenon than countless papers about what should happen. In his second presentation, Professor Rozhdestvensky focuses specifically on applying lifting line theory to large aspect ratio wings in ground effect. He explains that while classical lifting line theory assumes the chord is much smaller than the span, ground effect introduces distance from the ground as an additional critical parameter. For lifting line theory to apply effectively in ground effect, the ground distance must be comparable to the span, allowing proper application of these analytical tools. Rozhdestvensky provides historical context, referencing early observations by the Wright brothers and pioneering work from Clermont Adair in the 19th century. He develops mathematical models using integral differential equations to simplify the complex problem of analyzing ground effect on wings, focusing particularly on extreme ground effect, where the distance to span ratio approaches 0. This limiting case produces significant interactions between the lifting line and its mirror image in the ground, creating complex flow dynamics that can be modeled with ordinary differential equations. The presentation concludes with practical applications for optimizing wing loading distributions and understanding the differences between span-dominated and chord-dominated ground effects. This video features an in-depth discussion with Dr. Hanno Fischer about his work with Dr. Lippisch, the father of the Delta Wing, in developing airfoil boats. Fischer describes the progression from the Mark X112 prototype through to the X113 and X114 models, detailing how these vehicles demonstrated exceptional flight stability with lift-to-drag ratios exceeding 20 at optimal conditions. The X114 featured retractable landing gear for amphibious operations and could take off in 350 meters at sea states 1 to 2, demonstrating remarkable versatility. Fischer demonstrates the user-friendly airfish model, designed to be operated like a powerboat without requiring flying lessons or pilot license. With a maximum speed of 130 km an hour and economical cruising at 100 km an hour using only 35 horsepower, the airfish could travel approximately 300 km on ordinary gasoline. Constructed from non-corrosive materials like glass fiber reinforced plastic and aluminium alloys, the craft featured innovative, pivotable winglets adjustable with a push of the button. Fischer demonstrates the craft's ability to glide over waves, clear obstacles to 5 meters high using kinetic energy alone, and operate effectively in congested waterways. He discusses safety features including spring-loaded dampers for water impact reduction and future development plans for a 20-seater version, emphasizing the importance of natural stability to reduce the reliance on electronic systems. The final presentation shows Hanno Fischer's rigorous flight testing methodology, emphasizing how theoretical predictions must be validated against real-world performance. Fischer describes constructing precisely scaled models equipped with measuring devices to capture essential flight parameters including speed, angle of attack, and pressure distribution. Models are controlled via long cables to transmit power and monitor performance without battery weight, with integrated cameras and sensors monitoring airflow and detecting disturbances. Fischer details both aerodynamic testing in various conditions and innovative hydrodynamic testing using a high-tension cable system in tow tanks, allowing models to achieve higher speeds and simulate realistic takeoff and landing scenarios. The development of the two-seater Hoverwing validated performance predictions, with extensive data collection during test flights measuring horsepower, thrust, and pressure. Fischer demonstrates the mechanics of executing jumps, explains emergency landing procedures, and showcases the introduction of direct control technology as a significant advancement in maneuverability and safety. The successful testing results demonstrate compliance with regulation requirements for hovercraft performance, including takeoff distances, turning radii, and weight capacities, proving the technology's readiness for commercial applications. Footage from Eages 2001 isn't just historical curiosity, it's a window into a moment when visionaries from around the world came together to share decades of hard-won knowledge about ground effect technology. From Edwin von Opstal's commercial vision to Hanno Fischer's innovative hoverwing designs, from the massive Russian Ekranoplans presented by Sinitsyn and Maskalik, to Professor Rozhdestvensky's elegant mathematical theories, and from Gunther Jörg's efficient Flareboats to Graham Taylor's hands-on model building approach, this symposium captured the full spectrum of ground effect development. The fact that this footage is now being digitized and shared on the SSG Aero channel means a new generation of engineers can learn from these masters. The mathematics and physics might be complex, but the core idea remains beautifully simple. Sometimes the best way forward is to follow the path of the pelican, flying efficiently just above the surface. Please do visit the SSG Aero channel, and I will post links to all the videos in the description of this video. For now, thank you for watching, keep in the loop by hitting the subscribe button, and we'll see you here for the next episode of One Wingspan Above. Keep on skimming.